So let's do this one then, which I mistakenly wrote on the board, but we might as well do it now. Okay, so here again, inverse tan. What am I going to do with it? I'm stuck here again because I have to use integration by parts, but I don't want my inverse tan to be my dv because I don't remember what the integral of inverse tan is. So that means I have to make my integral, my u inverse tan, and my dv is going to be that. So it might be a little garbagey, right? Because this is now going to be theta squared over 2. Now this du inverse tan is going to be 1 over theta squared plus 1. Okay, so this isn't terrible, right? It's not terrible, but it's not really awful at all. I did have to remember what this is. Oops, forgot my d theta, right? So then uv minus v du, I'm going to pull out the 2 here, theta squared over theta squared plus 1 d theta, right? And we just had this in the previous one, right? We had a u squared over u squared plus 1, so you can make that like 1 minus 1 over u squared plus 1 and go on from there. So really, it's not necessarily that bad. You don't have to freak out whenever you see an inverse tan, but of course, it could have been a lot worse. So, all right, let me do a couple more. Oh, there's only one more here on my list. So I'll just do that one. Or maybe we'll just pick some other ones. So let's see. This one I wanted to remind you guys, because we haven't done anything with absolute values in a while. So I just wanted to do one with absolute values just to remind you that what to do when you have an absolute value, which is, of course, break it up. So for the absolute value, I won't give you one with an absolute value that isn't a definite integral, because then it's really not clear what you're supposed to do, right? So for the absolute value, it should be a definite integral. You see it's a definite integral here from -1 to 2. So what I have to do, right, absolute value of u is u for u positive and negative u for u negative. Doesn't matter where the equals is. So what I have here then, absolute value of e to the x minus 1 is going to be e to the x minus 1 for e to the x minus 1 positive and negative of that for e to the x minus 1 negative. So what does this mean, right? E to the x minus 1 positive is e to the x greater than or equal to 1, but we know what that is. That's x greater than or equal to 0. So this is nice. Right? So we did need to solve that. But once we have this, then we know what we're doing, because we know we're going to break this at 0. This piecewise defined function is going to be broken up. So from -1 to 0, x is less than 0, and this is my piece here. And then from 0 to 2, x is, of course, positive, so then I'm using this piece here. And that's going to be my answer. Okay, so those are easy enough to evaluate. It was just a question of the absolute values in this one. Right, on here I am. Only 4 minutes in the video. I better do another integral, right? What do we got? What do we got? I don't know. I don't know. What about this? Secant theta, tangent theta. Oh, that's easy. Well, maybe not. Let's see. Ah. That's a good point. Secant squared theta minus secant theta. Okay? So, kind of interesting question here, because the very first thing I thought to do was, oh, well, we'll just get rid of, there's too many secant thetas, right? So if I cancel this and I cancel this and I cancel this, what happens? I have tangent theta over secant theta minus 1. Now this starts looking worse though, right? Because I don't have any squareds or anything. I don't have anything really to work with. I can start putting this into sines and cosines. If I put it into sines and cosines really quick, I think, wait, sine over, this is, I'll just write it up so I don't screw it up. Over 1 over cosine theta minus 1. So this ends up being something like this, like one of those weird ones we did where we had to multiply top and bottom by 1 plus cosine theta and got the cosine theta squared. It's so, yeah, you can do that. But in fact, I'm like, wait a minute, look at this though. So sometimes it might not make so much sense to start simplifying right away, because when I simplified, I actually made my life worse. If I look at it just like this and I realize that secant tangent is the derivative of secant, instead of going like this, I can do u equals secant theta, du is then secant theta tangent theta d theta, and this becomes du over u squared minus u, which is u times u minus 1. So yes, that's partial fractions, but it's a super, super easy partial fractions. Like it's like 1 and 1 on top of something like that. It's really easy. So give it a little thought. Like, so if you start some way and you end up with something that is like not helpful, maybe go back to the beginning and say, was there another tactic that I might have taken?